Hi, I'm Rhett Jesse, and today we're going to talk about the Metrix Digital Proximity System. Now, what we're going to talk about is the once per turn phase trigger, or a once per turn marker, also known as a key phaser, but I'll be using phase trigger for the remainder of this discussion. So your monitoring system relies on an accurate phase trigger. If you don't have one, transient data is going to be inaccurate. 1x amplitude and phase, 2x amplitude and phase, not 1x, nx, those will all be garbage without a good phase trigger. So how do you get one if after installation you have everything you thought was going to be working right, you don't have a good phase trigger? Let me describe. Let's say in a normal installation, you'd want to have the notch line up with the probe completely. So we have it gapped at 8.3 volts. You'll notice that when I turn the wheel and go to the notch, it goes to 23, almost 24 volts. Okay, so that's the change in voltage. So that's a very good phase trigger. Let's go ahead and start this machine up, and when we do, we'll be able to see how big the pulse is on an oscilloscope, and we'll see that, hey, that makes sense. Hey, right, you've set it up correctly, everything works. But then we're going to show you what happens in an abnormal situation. So let's go ahead and start with what normal looks like. I'm going to go ahead and put on my safety glasses. I'm going to run this machine at 3,600 RPM, and we'll take a look at the voltage pulses we get. And we're going to look at that with an oscilloscope. And right now we're getting about a 15 volt pulse, and that's what we'd expect. I'll go ahead and stop sampling here for a minute, and we'll get an accurate pulse. It's about 16 volts. We were at a gap of 8 plus 16 is 24, so that's just about what we expected. And that's an adequate pulse for any monitoring system. But let's say it's not that good. Let's make it far worse than this is. So I'm going to go ahead and stop this, and I'm going to change the orientation of this probe with respect to the notch. And let's just say we made a mistake during installation, or maybe there's a problem. So here we have our notch and phase trigger lined up pretty well. I'm going to go ahead and change the angle of this probe, and we're going to move it out to where my gap is less. So I'm going to make it so I have at least some voltage. We'll go to 19, a little bit more. Okay, so now we have a gap of 19.46, so we're not going to get a great pulse. If we go to where the notch is, it's 23, so we'll probably get about a 4 or 5 volt pulse. And we'll see if we can make it better than that. Let's see if we can make it a little bit worse. Alright, so I'm at a gap at about 21.6, so I'm not going to get a very good pulse out of this. Let's go ahead and start it up and see. Okay, so I've adjusted the probe so we're really not lined up with the notch and the phase trigger. And you can see we're going to have about 2 or 3 volt pulse, and that's not going to be adequate for the monitoring system. So let's go ahead and start it up. And we'll look at it on the oscilloscope. Let's go ahead and look at it. So we don't have a very big pulse at all. Sometimes a double pulse, which is not very good at all either. But a 4.5 volt pulse. What we want to do is use the Digital Proximity System software to make that pulse height larger. Let's see if we can get it above 6 volts so we have a good adequate pulse for the monitoring system. So, and this was without changing, going inside the machine and changing where the probe is oriented. We're going to just take this pulse and see if we can make it better. So to do that, we use the Digital Proximity System software. We connect to it via the USB connection at the bottom. You take off the DIN rail mounting, you'll be able to connect to it. And then you go to the Advanced Settings tab. In the Advanced Settings tab, we have quite a few features. One's crosstalk elimination, but another one is the speed pulse adjustment. And that's what we're going to use right now. So I'm going to go ahead and adjust the pulse. I'm going to go ahead and say get, and we're going to look at the pulse height. So it's at 3.64 volts peak to peak. I'm going to see if I can make that larger. And you can move this slider either to the left or to the right. I'm going to go ahead and move it to the left and see the effect. Now if it makes it worse, I know I have to go the other way. Let's go ahead and get peak. Okay, it went to 0, so I made it far worse. That's terrible. Let's go the other way and see if we can make it better. You have to let it update, and then you hit get peak, and we'll see if we had positive results. Okay, now we're at 4.72, a little bit better than what we had before. Let's see if we can get it above 7. Keep moving it to the right, let it update. After it updates, you hit get. Okay, 5.72. We're going in the right direction, that's good. Let it update. We say get. 7.3. Now we can keep going and making it better, but you'll find a point where it'll just drop off. That's because we've gone out of range. So we'll move it just a little bit more, see if we can make this pulse a little bit better. You say get 7.48. That's a really adequate pulse for any monitoring system, and we're going to go ahead and go with that. And now let's go look at our oscilloscope screen to see if we have that 7.4 volts peak to peak. And you can see on the oscilloscope we're at 8.9 volts peak to peak. So that's a really good change from where we were before. Well, first of all, we started with the probe nicely oriented with the notch, and then we went to the probe being askew the notch. In other words, due to a thermal growth problem or a thermal change, the probe is no longer lined up, and you can see that it's not very nicely lined up, but we can still get a good adequate pulse because we can change the scale factor in the digital proximity system. Now you never want to do this for a vibration sensor or a position sensor, or when you're using it that way for a thrust transducer or vibration, but for speed you can. And this is where you get the value from the Metrix Digital Proximity System. You can get a great voltage pulse for your phase trigger, and that's what you can use in your monitoring system. Thank you very much.